Compensating for the limitations of growing old is a far cry from experiencing the devastating effects of the disease we now call Alzheimer's. For many years it was believed that if we lived long enough, most of us would succumb to such dementia. Now leaders in the battle to find a cure for the disease, men like Peter Davies, have dramatically changed the way we view Alzheimer's.
I really don't believe for one moment that Alzheimer's disease is a consequence of aging or an extension of the aging process. It's a specific disease quite distinct from any of the effects of age. The effects of age on the brain are minimal, absolutely minimal. There are many diseases, many pathologic entities that can affect the brains of elderly people. But I do not believe there's good evidence for an effect of age alone on the brain. In my own view, it's entirely possible that Alzheimer's disease is always genetic. But you can't see the genetics. You can't see a pattern of inheritance because the ancestors, the relatives of the patient, simply didn't live long enough to develop, for you to know whether they developed the disorder. We really don't understand how a genetic error that's present throughout life, how that begins to produce a disease, what triggers the onset of the disorder.
Identical twins Bert and Hugh, now 81, were raised together and lived not far from each other. One of them must have confronted the trigger for Alzheimer's, for today he exhibits the symptoms of dementia.
We had some kind of a thing that we could go up there, but it was too far to go. Because nobody, I don't think, ever went up there at all. They go out in the waters.
Well, in looking back on this change in Hugh, it was not perceptible, but something in our relationship had sort of slid apart. And that would be 3 years ago or 4 years ago. By 3 years ago, there were gaps and phrases and cover-ups on his part. You know, I didn't pay much attention to it. But looking back on it now, it seems to me that this was part of the beginning of some kind of change of mind.
And what's your memory like now? Is it as good as it used to be?
Oh, it would come back quickly.
You think that if you tried to remember a room full of names, you would be able to do it?
Yeah, I'd be able to do it, but I'd have to tune up a little bit on it, like golf or anything. You have to get going on the thing.
I have some pictures here. Maybe you can tell me what the names of them are. What about this one? Can you tell me the name of it?
Well, I'm thinking you could play some kind of machine.
It's sort of like that, except you put it in your mouth. It's something you blow on.
Oh, I know what you mean.
Yeah.
I can't remember the name of it, though.
Begins with the letter H. Sounds like...
I'm just on the edge of it. I can't quite get it. You blow it through here.
That's right. That's right.
Children have it, don't
That's
they?
right. Exactly. Exactly. Right. What about that?
Oh, that's a wonderful one. That's a terrific thing. Way out in the bush.
That's
right. Out in the bush with
right.
Great big things going around, and they're going to wipe people up.
Yeah. And Africa is where they live, don't they?
Yeah.
Do you know what it's called? Begins with an R. Sounds like R.
Veronica, I can almost get it, but I can't quite get it.
Rhinoceros?
Rhinoceros,
right.
That's it. Yeah, I got a big thing
That's
sticking out. Then I got to do it.
We now believe Hugh is unable to succeed at this child's game because of accumulating deposits called plaques and tangles in the higher regions of his brain. At the core of the plaque is a recently studied protein called amyloid. Around it, nerve terminals have begun to degenerate. Tangles are composed of two filaments wound around each other in a helix. While these structures also exist in the brains of normal elderly, only in those suffering from dementia, like Hugh, do they proliferate.
I sometimes worry about myself. I mean, I have this, maybe this inheritance. My father had Alzheimer's or some kind of a dementia, a similar dementia. Our oldest sister, Marty, has been 6 years in a home, nursing home in California. And I find myself, but after all, I'm 81 years old, and anybody that age has to grasp for words.
One of the latest techniques used to study the brains of individuals with Alzheimer's disease employs three-dimensional computer imaging technology. A leading researcher in the application of this technique is Dr. Aaron Bigler at Brigham Young University. Dr. Bigler has contributed to our understanding of Alzheimer's disease through research that has used magnetic resonance imaging, or MRI. He has also used this method to evaluate the brains of identical twins, one who is symptomatic for Alzheimer's disease and the other who is not.
What we're going to look at now is the typical magnetic resonance imaging finding in Alzheimer's disease compared to a normal control. In the view here on the left, this is a classic Alzheimer's patient, and what we see is temporal lobe atrophy manifested by this white area, increased ventricular size. These are the temporal horns of the lateral ventricle moving back to what is referred to as the atria. And here is the lateral ventricle of the brain. All of this is very enlarged when compared to the normal control subject over here. And then in this view, we see extensive wasting of both frontal and temporal lobe regions, as well as parietal region of the brain in the Alzheimer's patient. So global atrophy, particularly frontal, temporal, parietal, and dilated ventricles everywhere, and very distinctly abnormal when compared to a control subject. In this particular study, what we have compared is a patient who has Alzheimer's disease compared to his twin brother, who is an identical twin, who at this particular stage in life does not have Alzheimer's disease. This is the twin that has Alzheimer's disease. Here is the twin that does not. In the middle is an age-matched control. The type of magnetic resonance scan that we have here is one that highlights the cerebrospinal fluid spaces of the brain. These will be the white areas. And so the sulci, or the crevices on the surface of the brain, and then the internal cavities. If you compare this one, who has Alzheimer's disease, to the twin who does not, you can see that the brains are very similar in appearance. That should come as no surprise because an identical twin is identical, typically in their face, their body type, and we now also know through magnetic resonance imaging technology that their brains are in fact identical in appearance. If we take the unaffected twin and we colorize all of the CSF space in red, and then we take the AD twin and colorize everything in green, and then we bring the two together. Well, red and green make yellow, and so wherever you see yellow, you will see a similarity in the brain. And wherever you see green, that signifies the Alzheimer's twin who has a bit more atrophy. But I think what is remarkable about this scan series is that the unaffected twin has signs of atrophy of the brain. The more we learn about Alzheimer's disease, the more we find out that there may be some significant genetic control factors at play in the evolution and development of Alzheimer's disease. And that is what this imaging study suggests.
Thus, Dr. Bigler's research indicates that if one identical twin has Alzheimer's, then the other one will, if he lives long enough, most likely develop it as well. More recently, Dr. Bigler has begun an epidemiological study that may lead to earlier diagnosis and better management of this disorder.
We've had the opportunity this last 2 years to initiate a large study of the brain imaging abnormalities associated with Alzheimer's disease. I've had the great fortune to connect with Dr. John Breitner at Johns Hopkins University, who is the principal investigator in this research project that is testing everybody who is 65 and older in a county in Utah. After testing all of these individuals, those who were suspect to have Alzheimer's disease or some other type of dementing illness have undergone more extensive studies, including magnetic resonance imaging of the brain. And I have had the opportunity to be involved in analyzing those brains with what are called quantitative magnetic resonance imaging techniques. This is a quantitative imaging technique displayed on the monitor now, showing how we can isolate the different regions of the temporal lobe here into the 5 gyri that compose the temporal lobe, and also this critical structure, the hippocampus, which is vital to short-term memory and is one of the pathologic sites for Alzheimer's disease. We have, in this population, quantified these regions of the brain, and in particular the hippocampus. It is well known that the hippocampus is affected by Alzheimer's disease, and we have gone in and demonstrated quantitative changes in the hippocampus that can be identified by magnetic resonance imaging. We anticipate that these improvements in diagnostic imaging and quantification will lead to much earlier diagnosis of Alzheimer's